Hi students, today in this class we will discuss about Fisher's structure of glucose. So glucose chemical reactions and properties and structure also we discussed. So after many studies some structures is available for glucose. That structure is CH2OH 4. That means 1 2 3 4 5 6 carbons. So OH H OH and OH, this side H OH H. So like this, 6 carbons and 12 hydrogens and 6 oxygens present in this. This is one structure, name is glucose. And then COOH, here also CH2OH 1 2 3 4 plus 2 6 OH H OH OH H OH H H. So this name is gluconic acid. This is structure number 2. Next saccharic acid also is there. COOH COOH 4. Here OH H OH and OH H OH H H. This is saccharic acid, structure number 3. So Fisher's structures we will call this is FISC HERS, Fisher's structures. So in these three structures he explained. After many studies, glucose having 3 different structures, that is these 3, like he said. So according to him, next we have one alpha D beta D glucoses is there. No, about that how we will write alpha D and beta D glucoses and all. So we have one glyceraldehyde formula, glyceraldehyde what? CHO and CH2OH and then OH H. Same one more OH H CHO CH2OH. So see this one difference what in this two OH. Here in this compound OH is left hand side is there, in this compound OH is right hand side is there. This one we will call plus plus glyceraldehyde. This is minus glyceraldehyde we will call. So what is the difference here? Here difference is glyceraldehyde, this one will give plain polarized light, we can pass through the this glyceraldehyde. It will rotate clockwise. This molecule will rotate clockwise, this molecule will rotate anti-clockwise. Clockwise we will call plus, anti-clockwise we will call minus. That only difference. Clockwise also called as dextro-rotatory. Clockwise we will call dextro-rotatory. Anti-clockwise are L means leo rotatory. dextrorotatory, L glucose, D glucose, like we will learn now. So L means levorotatory, D means dextrorotatory. That is the difference. Okay, next alpha, beta, that and all is there, that we will discuss later. Now this is L glucose and D glucose differences. So Fisher is said 3 different structures. So we have one glyceraldehyde. So according to this one, dextrorotatory means plus glyceraldehyde. This is shows OH right hand side, here OH left hand side is there, means this is levorotatory or minus glyceraldehyde or L rotatory we will call. Okay, next cyclic structure of glucose. Cyclic structure, it is cyclic structure, it is available or not? Cyclic structure, so we will check. So normal structure glucose have some drawbacks, that is glucose number 1, this one, molecule number 1 have some drawbacks. The drawbacks what? The drawbacks is deposit aldehyde group deposit having the aldehyde group glucose does not give 2,4-DNP test. Glucose, some drawbacks is there, no, that is 2,4-DNP test. Normal glucose didn't give 2,4-DNP test. That is what 2,4-DNP when react with glucose, what products will come, that didn't give. Next, Schiff's reagent, Schiff's test also does not form the hydrogen sulfide addition product with sodium hydrogen sulfate, SO3, sodium bisulfite. It did not give this one when react with glucose, do not give this one. Next, second one, pentacetate of glucose does not react with pentacetate. Yesterday we discussed, no, pentacetate means 5 OH groups present. So acetate CH3COO attached to the where OH is there, that place I said. So pentacetate of glucose, pentacetate of glucose, pentacetate of glucose does not react with hydroxylamine, does not react with hydroxylamine, indicating that what? Absence of free CHO. So that means what? Does not react means that indicate that free CHO group not there, not having, that means. But CHO group is there, no? CHO group is there, but didn't react. Normal chain or a straight structure of glucose does not gives this tests and all. Next, one more is there. Glucose is found to exist in 2 different crystalline forms, which are named as alpha and beta. Yes, no? It is a 2 crystalline form, alpha and beta structures. Beta glucose, alpha glucose. The alpha form glucose melting point is 419 kelvins, and beta D glucose obtained by the crystalline structure concentrated solution glucose 303 Kelvin. It is generally 303 Kelvin only, but it will use like this. This is one drawback. Next, beta form 423 beta form 423 Kelvin, but it is obtained by crystalline solution from hot and saturated aqueous solution at 371 Kelvin. So difference is there, no? So this is the alpha and beta D glucoses drawbacks. These three drawbacks: it cannot react with 2,4-DNP test, and it cannot react with as well as hydroxylamine. It indicates that absence of CHO, and then 2,4-DNP it cannot react, and Schiff's test also didn't give hydrogen sulfide addition product with NaHCO3, it cannot form. So these are three is drawbacks. So next, after drawbacks, what we will do? After drawbacks we will discuss about structure of glucose, how it is a structure, what is alpha and what is beta. Alpha beta we are discussing. No, what is alpha beta? See, alpha D glucose and beta D glucose, how it will form. So according to normal glucose. So I will explain. Glucose structure is generally how it is CHO. That C I will write here C double bond O H. CHO only, no? CHO 1 2 3 4 CH2OH down. So now here OH HOH. This side OH is there, means opposite OH only. So here OH, here H, here also H. Sorry, here also H. So this is from this structure we will get two different structures, that is cyclic structure. Now heading only that only, no, cyclic structure of glucose. So some failures is there, some drawbacks. That drawbacks I discussed. So after that, it normal glucose didn't give that one, but cyclic glucose is gives positive tests and all. So now what is alpha D glucose and beta D glucose, I will explain. Here this OH hydrogen, this OH goes to here, attached to this carbon, fifth carbon going to first carbon, fifth carbon OH group attached to there. Then what happened? That C having one H, this H, and I am send one OH group, no, that is this OH group. Then this O is there, no, that O will form like this, CH2OH 1 2 3 4. So here one H, one more H, same like this structure. Here OH, H, OH, here H, here OH. This is one structure. Here OH, O group, here this oxygen I am writing like this cycle. So 1 2 3 4 5 carbons cycle like it is there with this oxygen, 6 carbons total. Okay, that I will write other structures. That structures we will call Haworth structures. So now this is what OH group left hand side is there, no? So now this one we will call beta D glucose. Beta D glucose. This is positive. Positive means before on structure we discussed. So alpha D glucose, beta D glucose. Positive and negative. Dextrorotatory. D means dextrorotatory. Beta. Dextrorotatory. It is beta. This OH this side is there, means we will what I said, that is beta glucose. Next this side one more structure, alpha structure I will draw. So same structure, C, this side OH is there, this side H, here O like is there. So then CH2OH. So here I am writing this one like H 1 2 3 4. Here HOH. Here OH HOH. Then this one is HOH H. Now this is OH is right hand side. This is alpha D dextrorotatory glucose. Alpha D glucose and beta D glucose. This is glucose. So now understood alpha beta D glucoses. This is alpha D glucose. This is beta D glucose. The difference in one carbon. That carbon we will call anomeric carbon. What is that? Anomeric carbon. Only difference in alpha and beta glucose is anomeric carbon atom. Anomeric carbon atom only difference is there. Remaining all same. So that is alpha and beta glucose. This one we will write on the structure like a ring cycle. We have 5-membered ring. One is there, 6-membered with oxygen. That what pyrone. Okay, we have one 6-membered ring with along with oxygen. That pyrone, PYRAN. Okay, according to that, how will you write? How will you write this one and this one? These two structures. That structures one scientist. That scientist name is Haworth. HAWORTH. Haworth structures. That structure is very stable than remaining. So how it is? How he wrote? See, this 1 2 3 4 5 carbons and this one is 6. Furan structure you know, that is oxygen, like this is there. So this is now furan structure. According like this we will write Haworth structures like this. This is also same, no? Same. Now one more structure. This is one thing. This is two structures, no? Two Haworth structures I will write. So difference in the compound is only one carbon, that is anomeric carbon, that is this carbon. This carbon we will write number 1. This is 2. This is 3, 4, 5. Sixth one here is there, CH2OH. This is 5th carbon. This is a 6th carbon. Now this is 1 2 3 4, no? This is first carbon. Here only difference is there, hydrogen. So that I will write here. So when we are writing here OH up, that is outside OH, this one, this structure. Outside OH is there, that we in this structure we will write outside. Inside OH groups we will write here also inside. Here also inside. How we will write? See, OH and H, second carbon H, second carbon H OH, second carbon HOH, third carbon having 1 2 3, third carbon having OH inside, H outside, and fourth carbon OH down. Inside OH groups, all inside OH groups we will write down, not inside this structure, down. So outside OH groups we will write inside. So outside OH group, this is outside, no? In this line this is outside, this is there in this structure. Here third carbon. See, 1 carbon, 2 carbon, 3 carbon, third carbon atom OH group is inside. So outside 1 2 want. See, here 1 is there, here also one more, fourth carbon. See, fourth carbon have here in this cycle inside is there, but here outside is there. Then here hydrogen. This is the then CH2OH, and this side one hydrogen, that is this hydrogen. Okay, this is Harvard structure of beta D glucose. Beta D glucose plus beta D glucose. Beta D glucose, but name now this is glucose or not? Glucopyranose. Glucopyranose, like we should write pyranose, because pyran from it is comes from, that's why. Now in this structure, this is anomeric carbon, no? Anomeric carbon. So anomeric carbon only difference. So we will write here OH down, H up, that only difference. Next same CH2OH here, hydrogen here, OH down and H up here, OH, H here, what, OH and H. This is alpha D plus glucopyranose. So this is the names. So first carbon is this one, second one, third one, fourth, fifth and sixth. Same this one as 1, 2, 3, 4, 5. Sixth one is this one. So this is the Harvard structures of glucose. Alpha D glucopyranose, beta D glucopyranose. Difference where both are same, no? Difference first carbon. See here H up, here down. OH here up, here down. So this is only difference. Harvard structures, anomeric carbon difference only. These two we will call epimers also. What is that? Epimers. Alpha D glucose, beta D glucose are epimers. Okay, next class we will discuss about sucrose, maltose, lactose, like monosaccharides and disaccharides preparation. Not how it is formed, that we will discuss. Okay, thank you.